Okay, we're recording. So my goal today is just to keep it simple and give some sort of introduction to my own research programs. It is way too time consuming to start editing these videos, so I'm just gonna go one shot here and keep this under a time limit under 10 minutes just to give some intro to my work, and I have to add another video. Now here is my GitHub page. J.H. Martel is my name. Justin Harry Martel. Thank you very much. Nice to meet you. Who am I? Just a mathematician trying to make a name in history. I've had a long time in mathematics, a long time to work on things. This GitHub page is sort of just a brief segment of what my main projects are. I'd say I'm a tree with 6-7 branches that I'm really developing. My first passion is here, my thesis, Topology of Singularities. And the point of this is just to have finally uploaded some document to the archive. It took me so long to get this here. That reminds me, there should actually be a link to the archive in the README, which I didn't do. Yeah, I will do that at the end of this video. The next topic seems kind of controversial, but special relativity. And this brings us to fundamental physics. I'm also working on, basically there's a lot of questions about light, especially light in vacuum. These days I'm also getting fast pages, thanks to my friend Krishan for giving me a website here, and I'm trying to be more productive and post some of my work. I think this one's the most interesting. Everyone's heard of E equals mc squared. It's a beautiful question what it really means. Very beautiful question. Now, Einstein, and in general relativity, it's very interesting some mathematics there. Einstein's Hamiltonian, where they kind of hypothesize the existence of a intrinsic energy to m, where m here, it's very important to say, represents mass. And mass, if you know your history of physics, has two definitions. One is the inertial energy, especially in the kinetic energy, inertial mass, and the other is the gravitational mass. Einstein hypothesized in his general relativity and special relativity, that in his thought experiment, of course, that there's always a reference frame, where the gravitational force can just be viewed as an acceleration. Now, that's controversial, especially as it's admitted, especially when it comes to Machian physics. I'd like to give more pointed, more specific criticisms, but that's not the place here. E equals mc squared. I'll give you the point here. And this is studying electrodynamics with Weber's force, which was derived from Ampere's force between two current elements. For example, the fact that two parallel current elements attract, and that causes parallel currents to inward spiral towards each other, as Electric Universe points out in the filament structure of matter distributed in the solar system. Beyond the solar system, galactic universal system. Now here the idea is that everyone's heard that opposites attract, and that like charges repel. Well, Weber's understanding was that if you have two opposite charges, it takes force to push them together, push them closer together. But if you have enough force, there's enough energy that can be put to work, there is a threshold, a critical threshold, where you can push them together, and then finally they become together and they become attractive, a stable system, once you get through that threshold. And that's what the value of E equals mc squared is. It's the amount of energy required to take two oppositely charged particles and bring them together. And in that sense, is it found that atoms can be sources of abundant energy. Because, why? Because in this system there has been work that's been invested to bring these two attractive particles together. And then the question is, how can you cause them to release? Of course, the idea is that there's a big hill, and if you put enough energy to bring the particles up the hill, well, inside the hill there's a bowl, and they can be very stable inside the bowl. That's just one view of the Weber here. So, this is my style. Obviously, there's a lot of theory. There's thought beforehand. You come up with your hypotheses. You come up with your equations. Oh, there's no equations in this one. Let's just go to a previous post. A letter to Professor Assis. Conservation of energy. This is very important. So, here's this potential energy. It's like Coulomb, except it depends on relative velocity. Very simple Python code. And this is the beautiful, attractive structure. So the point here is you actually have you actually have equally charged particles, like 2 electrons. And if you put in enough energy, E equals mc squared, where m is the rest mass of the electron, then you can cause them to be past the critical radius where they become attractive and very stable. And that, in that sense, they become a source of energy. E equals mc squared amount of energy. What is the mechanism for popping them out of the hill? There has to be something. Basic Python code. I'm a simpleton when it comes to this stuff. Obviously, I have a lot to learn about workflows and Docker. Should I take a course on that? So much time, eh? I mean, not so much time, so much stuff to learn. My instincts these days are just keep it simple. Keep it so simple you can understand it. Now let me throw in another topic here. This is kind of abstract. It's not really abstract. It's fundamental physics, which thanks to Orion Energy and Electric Universe is being transformed. I have my Dol-Tom, homology and optimal transport. I have to work on that. Medial axis theorem, projective homogeneous varieties, some ideas on the sponge, mapping class group, I love that. Some older things. Now what's the point I'm trying to make here? See, I'm not good at these videos, right? Supposed to be finding a job here. It's all about keywords and verbs or action words. And relate your past experience to how you're going to help the team and how you've changed teams that you've worked on and how you've bettered things. I am really unskilled at that. But I just gotta keep working on it, I guess. I mean, this video is part of me just trying to brand myself better, give people some kind of idea of what I'm working on here. I made mistakes during my academic career. I was given a lot of freedom, and I really took advantage of that freedom to, I would say, study all of mathematics. And then I was encouraged to only do that mathematics that speaks to you, and that mathematics has to be geometry. It's much more, you experience it a little more and can discover things in it. You don't necessarily have to predict them beforehand. Meaning, not all of mathematics is syllogisms and deductions. There is a part of it that's about exploring. You don't know beforehand what's true or not true. It just depends on what universe we live in. I always find that interesting. Maybe I should shave and get a haircut. I gotta work on all that stuff. It's just the mad scientist vibe.